Alright, so today we have been working on, up to this point, we've been working on adding and subtracting to solve an inequality. Then we went to the next step of multiplying and dividing to solve an inequality. When do we switch the inequality sign? Joshua? When you divide or multiply. Make sure you only use multiplication division for that, because it doesn't matter if you add or subtract a negative, that won't switch it. Just multiplying or dividing. Okay. I'll do you want to know so you're doing math. Okay. After we looked at multiplying and dividing, we went to multi-step equations. So you had to add or subtract, move, and get your variables on the same side and your constants on the same side. Then we divided to get our variable down to 1, and that solved our inequality. Today, we are now going to work with compound inequalities. Before, we were always getting it to be like x is less than 5. Well, now we're going to see where it's going to be more than one answer. So, we'll work on this. Let's start with our warm-up, and that should get us in the right mindset. So, solve the inequality. What do I have to do first when I have 8 is greater than x plus 10? So right now my two parts of my equations are 8, and I know 8 is going to be bigger than what x plus 10 is. So right away, do I think x is going to be bigger or smaller than 10?
Smaller.
Much smaller, right? Because if I got rid of the x, 8 is not bigger than 10. So it's going to have to get smaller. So keep that in your head. How do I solve this, Andrew? Subtract what?
10.
Okay, so let's subtract 10. 8 minus 10 is negative 2. And we have negative 2 is greater than x. Awesome. So we are done. We now have constant and variable. Remember, we want to make sure we put our variable first. So this would have been that little foldable. I'll give you the flip-flop, the sandals. If I put my variable first and my constant second, if I flip those two, I have to flop what my inequality sign is. So x is less than negative 2. It's going to make it easier on you to put your variable first. Number 2, 6 is less than or equal to 2x minus 4. What are we going to do first on this one, Brianna?
Add 4.
Okay, so we're going to add 4. I'm going to do this real quick. I have this equation and this one. All right. So I want to add 4 to both sides. So I have 10 is now less than or equal to 2x. How do I get x alone? Braden. Yeah, let's divide it by 2. And we would get 5 less than or equal to x. What would be my equation if I put x first? Aaron, what would we get? I just want to rewrite this. 5 is less than or equal to x.
If you would have put it first, it would be 5. X is greater than or equal to 5.
Good job. Good job flipping your inequality sign. Okay, let's look at story problem. This is where we get tripped up sometimes. You estimate you can read at least 8 history text pages per day. What are the possible number of days it will take you to read at most 118 pages? I'm going to pause our video. I want you to turn and work with your neighbor. I want you to try and figure out what equation can we write for this. Alright, so let's go ahead and look at this. What was the equation that you guys came up with?
8x is greater than or equal to, no, less than or equal to 118.
Okay? So let's go with this. And how are we going to solve for x? We would simply just divide by 8. And x is less than or equal to 14.75. What are the possible number of days it will take you to read? That's what we were solving with x, on how many days. So if we have to say at most, can we read 14.75? No, we're going to say 15. But since x is less than, can I make this less than that? The biggest question is, did we use a less than and equal to, or our greater than and equal sign correct? What do you guys feel? So some of you thought it might have been greater than. It is actually still less than. She's got it correct. We have at least 15 days because she could read at least 18, or at least 8 pages. So she could read more, but I cannot go over 118. Okay? All right, so let's look at today's assignment. Today's assignment, I will solve compound inequalities. Okay, everything that's going to be here on OneNote. Okay, everything that I'm going to do on OneNote, I'm going to do instead on this green sheet that I gave you. A couple of you don't have green because I made extra copies. But this is important for our notes. All right. If I have to wait on you, we will not get through our assignment.
I was probably supposed to pass that to you guys.
Waiting on a couple people.
Sorry about that.
Okay. What this will look like, we're going to fill this sheet out together and then I'll show you how you should be gluing it into your notebook. But our first thing up here, it says compound inequalities containing and. Okay? So, the right thing. First thing, when we are working with compound inequalities, using the word and, you will shade the intersection.
Oh, come on.
Okay, so we want to make sure that we are
Go back to work.
Working on the intersection of this. Alright. So when we look at this one, we have -2 is less than x, and x is less than or equal to 1. This is a compound inequality. You notice how we could see that I have -2 is less than x. There's our inequality. But I also have x is less than or equal to 1. The way we shade this one in, this is an and. When it is written this way and your variable's in the middle and you have the inequalities on both sides, it's an and. And the way we do this is, I'm going to focus on this first one. And to help you, I'm going to look on the side. I'm going to flip-flop this. This would be like x is greater than -2, correct?
Yeah.
So what we go ahead and do is I first come to -2 and I'm going to circle it. Why is it an open circle? Very good. It's only the greater than. It's not greater than or equal to. Then I'm going to look at my other equation, which was this one. X is less than 1 or equal to 1. So I'm going to do a solid dot there. Then I shade the intersection. I'm going to shade what is in between them. So you can either shade like this, or I can go ahead and do my line like this. But this tells me, as a mathematician, when I look at this graph, if I didn't see any numbers, I just saw the line graph, I know my answer. I can choose any number in the world as long as it is bigger than -2 and it is at least 1 or less than 1. It could be 1 or it could be smaller than 1. Any number in between -2 and 1. So 0.75384221, that I know will solve my equation and make it true. -2 will make it incorrect. It will make it false. It will not work. 1.1 is too big. I know that will not work. When we look at this, I'm going to show you one last part. So it could be this and here. So I'm going to write both those down. When we work with and, we fill in between, the intersection. Okay. Compound inequalities containing or. If I look at my equation, I have x is less than -1. So I'm going to go to my -1. It's an open circle, and it is x is less than. So that means I should have an arrow going to the left. Or x is greater than or equal to 0. Solid dot. But since it's greater than, I'm going to have it going the opposite way. When we have inequalities, we're going to say shade the unions is what it's called, the math term. And what that means is I'm going to make individual graphs. That's all this is going to mean. You can tell because I am with the or, I'm having two inequalities, so I'm going to have two graphs. And even if I try to shade this, if you're just following your rules, you would actually shade it, correct? Because x is less than -1. Okay, well, that line has to go this way. X is greater than 0 has to go this way. If I went up back to my and, yeah, if I would have shaded -2 is greater than, I made my line all the way over there, that's okay. I'm going to show this on my paper. Don't do this. You can, I guess, if you want. If I went back up to this first one, I said x is greater than -2. I could have made this line. That shows me x is greater than 2. And I could have done it for the negative. But my answer, since it's a compound, your answer is the shaded one. The one that's in between both, that both get intersected. So let's try a couple of these. Flip your paper over and let's look at example number 1. I'll do this with you and then I'm going to have you do one by yourself or kind of with the neighbor. So graph the inequality. -4 is less than x, which is less than or equal to 9. I a lot of times like to do my flip-flops. I'm going to identify my equations. I have this one, so I know I'm going to be graphing x is greater than or equal to -4 and x is less than or equal to 9. So I'm going to go to the first one. So when I do my graphing here, I got to make my number line. And I got to pay attention. I know I have to go between -4 and 9. So I'm still going to put 0 and just go by 2's. -2, -4, -6, -8, so on. I graph my first one. X is greater than or equal to -4. So if I think about this, that means my line's going to go this way. I'm going to do x is less than 9. So here's less than or equal to 9. There's 9. it's going this way. So what is my answer? My answer, I'll try using a better color for you. My answer is the shaded region in between. So even if you do your lines on your work today, even if I drew the lines, you see my lines going farther. Use a straight line, a pencil, make your lines. But when you go to show me your answer, make sure you shade it in. Okay, I'm going to do the example number 1 underneath. That is an OR. And then I'm going to have you do 2, and then we'll check your answers. So, graph the inequality. X is greater than 5, and I'm going to 12. Ooh, since they're both positive, I'm going to start my 0 over here. You just start learning how you're going to zoom in on your number line the more you do these. But there's no correct answer for your number line as long as you cover everything. And I'm going to go 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay, X has to be greater than 5 or less than 5. So open dot. I'm going to let you know that's 5. And X is less than 5. So it goes this way. X is greater than 12. Open dot. And then we have it. Okay. I'm going to pause. I will come up and do this in a second. I want you to turn with the neighbor and try and do these next two. Let's clarify. All right, I want to clarify this. A couple of you are getting it. This is my fault. I forgot that they gave us the second example we're doing in today's assignment. If I look at this one, what was the difference on this one than example 1? Jackson?
It doesn't have two variable x's.
Well, example 1 only has one variable. Yeah, if I look at my previous ones, example 1, my variable, it went inequality sign, variable, inequality sign. -4, inequality sign, x, inequality. My variable was in between the two inequality signs. On this one, though, I have x plus 4 in between the two inequality signs. What this means is I first have to solve this. So, if I have x plus 4, the way to undo adding 4 is to
Subtract.
So I'm going to subtract 4, but I have to subtract 4 on both of my inequalities. So I'm going to do 3 and 11 minus 4, because you're really having two equations. If you need to break this down, I could have written this as 3 is less than x plus 4, and x plus 4 is less than 11. That is my two equations that we're solving. We're just showing how we do it at one time. I subtract 1. I get -1 is less than x. This is already canceled out. And I have 11 minus 4, so less than. 11 minus 4 is 7. I now get to graph this. If you want to do the flip-flop like I was with these ands, I would say this would be like x is greater than -1 and x is less than 7. A lot of times my students have found that this is easier to graph. So when I graph it, my number line needs between -1 and 7. So I'm going to go -4, -2, 0, 2, 4, 6, 8, 10, 12. X has to be greater than -1. So here would be open circle. There would be -1. And x is greater than it. So it goes to the right. X has to be less than 7. Open circle, there's the 7. My answer is what is shaded between. I'm going to use a highlighter. I'll show you how you could use your pencil or pen so I can tell your answer. I would just so you can see now with my pen or my pencil, if I didn't have a highlighter to show my work, this is my answer. My answer, x can be anything larger than -1 and smaller than 7, just like here on the graph. Looking at example 2, this one's a lot easier because with ORs, they break the equations up for you. Mainly, you know how the other day we just solved multi-step equations? You're just doing 2 of them for one problem. So instead of saying I did number 1 and 2, you're just saying number 1, but you're doing it twice. So, 3x minus 1 is less than or equal to 5. I want to solve that equation. I'm going to forget about the other equation for now. It does not matter to me. So I'm going to solve 3x minus 1 is less than or equal to 5. You add 1. 3x is less than or equal to 6. Divide by 3. X is less than or equal to 2. Okay? We go to our next equation. And right now I don't care about that first one. I have 5x plus 2 is greater than 37. I'm going to minus 2. 5x is greater than 35. I'm going to divide by 5. X is greater than 7. So, on today's assignment, it's going to give you questions like this, and it's going to say simplify. That is my first answer. I first have to simplify my equation down. So I don't say 3x minus 1 is less than or equal to 5, or 5x plus 2 is greater than 37. I do my work, and I'll say my answer is x is less than or greater than 2, or x is greater than 7. We graph it. I'm using the numbers 2 and 7. Since I don't really need much of a negative, I'm just going to start at -4, -2, 0, 2, 4, 6, 8, 10, 12, 14. Graph the first one. X is less than or equal to 2. Filled in circle, less than, goes to the left. X is greater than 7. Here would be 7, open circle, because it's only that, less than, to the right. Okay, real quick, like I said, I will make a video of your notebook today or over the weekend. So on Monday, you guys can make sure your notebook's all filled out. But it should go in your notebook. When you put this foldable in, you're going to see that you're going to fold these in half, so it's like this. You'll cut, so it just goes like this. And here's the rules. Here's our examples we did. Ors. Here's our examples we did. Okay? Let's go back to our OneNote. Okay. We have gone through all this. This is what was in your foldable. Compound inequality contains 2 separate inequalities. Sit right in your chair, Devlin. Joined by and or. We see on the left, these are ands. we shade in the intersection, just like their examples. Ors, it's the union. You see how they broke this into two. X is greater than 0, or equal to 0, so they graphed it. X is less than -1. They graphed it, so when they put it all together, X is less than -1, or X is greater than or equal to 0. And they have it graphed as, actually I should do that, I should show you it's 2.
So it can't be the area between -1 and 0.
Yep, because it's 4, so they're going to go opposite. Devlin, do you have your notes out and you're doing this with us?
I lost the purple note.
We might have to talk, you might cost you, because that's all your notes. Okay, so let's try this. Here's my question for you. We'll finish this up. We still have 10 minutes of class. Write an inequality that could be represented by the graph. So the first thing we have to do is decide, is it going to be an and or? When I look at here, this is shaded, this is shaded. Raise your hand. Is this an and or inequality? Aiden? It's an or. Good. So I know it's an or, which to me is easy then. I just have to write two of them. Let's write this one first. I know I'm going to start with X. Where's my dot at? It's at 7. So I'm comparing X and 7. Okay? Is X going to be less than 7 or more than 7? Less, because the arrow is going to the left. When we go to the left, we're getting smaller. Then my last question is it less or less than or equal to? Why is it less than or equal to? How did you know that, Aiden? The dot is shaded in, which means this is less than or equal to. We look at the one on the right. We're going to compare X and what number did it start at? Sean? 10. Hassan, is this going to be less than or greater than? Greater than. We're going to the right. And the last question is it just greater than or greater than or equal to? Alexander? And how did you know that? Good. Shaded dot equal to. I then make sure you write or in between. That is your answer. Number 2. Henry, is this going to be an or and?
And
How'd you know it's and?
because it's two lines that are shaded and like.
Alright, this is the one that gets people in trouble. So I want to make sure everyone pays close attention to this one. And becomes a little more tricky. First one is I got to choose my left dot. Let's find the left one, which is here. And it is shaded in. I'm still going to say I'm going to compare X and a number. Where we started at was 11. So I'm going to compare X to 11. Now, which direction did I shade? To the right. Huge hint. If we're doing and, when I do the first one, I'm going to be making this greater than. Is it greater than or equal to? Shaded dot greater than or equal to. That is this one. I'm going to switch colors. The other equation we have to compare. Our other dot is at 16. Now this time, my shaded region is going to go left. So it's going to be X is less than or equal to, since we have a shaded dot. Okay, we do not want to write our answer this way. We do not say X is greater than 11 and X is less than or equal to 16. We want to write it as an and. Here's how you do it. Take the equation that's on the left, the greater than one. Okay? let's take this equation and let's do our flip-flop. Flip-flop, we're going to change the order. So instead of x first, I'm going to say x second. And instead of 11 second, we put that there. What would be my inequality sign then? If we flip the order, Kate?
X is less than or equal to, 11 is less than or equal to.
Good. Okay, you see how we flip that? Everyone okay with that? It's not too difficult, we just have to make sure we can do that. All I did is flip the order, flip-flop, we changed the sign. We now just write these together, but I'm only going to use one x. I'm going to use this equation and this one and just merge them. When I write my answer, I will say 11 is less than or equal to the x, and there's my x. So I'll say is less than or equal to 16. This is our equation for and. Notice, your inequality signs are going the same direction. Because if it wasn't, if they were going the opposite, would I have an and? It'd end up being or. They'd go the opposite way. Okay. This was in our foldable, I believe, correct? Complete 3 and 4. Wasn't this in our foldable that we did? 3 and 4. X. Okay. These were in our foldable, so we've already done them. Because of time, I don't think we're going to jump on these last ones. So, here's what I'm going to try. I'll do the video, I'll finish these examples. So if you go to do your homework over the weekend and you're confused, make sure. I had a couple people ask me in my other math class, they're like, we went back to look at your video and we couldn't find it. Hey, remember, you have to go to my content library because I'm not pasting this on like Aiden's like I do sometimes. I'm on my content library. So you have to go to mine, and I will have the link at the very top of your page.